This video goes over the expressions and operations section of the Algebra and SOL from the 2016 objectives. Again, we're going to be using Desmos as much as possible and using it as a tool to solve these questions. So we're first going to talk about substitution questions. So for instance, when it says what is the value of the expression when x equals 2/3, and then they give the expression, they want you to substitute in for whenever x occurs. I cannot stress enough the importance of putting what you're substituting in parentheses. Particularly when you're using fractions or negative numbers, it's extremely important that you put them in parentheses. So my best practice tip for you is to always, when you substitute, put them in parentheses. So all I have to do is type in the Desmos, making sure you use the division bar to type in a fraction. I'm putting in parentheses. Notice the exponent goes outside of the parentheses. So I do 2/3 squared plus 3 times 2/3 minus 2. All right, and then I hit this button here, turns it into a fraction for me since my choices are as fractions. So the solution to this one is 4/9. Again, the biggest thing I want you to get though is when you substitute, you must use parentheses. That's the most frequent reason why people get questions wrong for the substitution questions. Here is another substitution question. It's -2 cube root of a plus b squared. Again, putting in parentheses. Notice when I typed it into Desmos, I put it in these parentheses. Exponent on the outside. If you didn't put this in parentheses, you would get the wrong answer. Just so you know where you get the cube root from, is if you go to the functions button and then you go all the way to miscellaneous, and then there is the cube root. I put a 3 in where that n is there, so I put a 3 there, and that'll do the cube root. And when I type that in, I get 17. So again, putting things in parentheses and where to find the cube root on this problem. Square root is just when you hit the keyboard, the keyboard icon, it's one of those choices for that. Right? Here's another substitution. So they want us to put -15 in for n. All right, so -2 absolute value, -15 plus 6 absolute value. To get the absolute value, you hit the keyboard tool, and then there's the absolute value symbols. There's the square root I was talking about for the previous slide. And when I type that in, I get -18. So again, substitution, put things in parentheses, know where your cube root is, your square root is, your cube, your squares, and your absolute value symbols. Which expression represents 4 less than half a number n? So what I want to do for this is talk about the 4 operations and the words that can mean it. So addition, subtraction, multiplication, division. So addition, you're going to think sum or more than or greater than or plus. For subtraction, you're going to think difference, less than, is less than or is more than. Those are going to be inequalities, but that if they say more than, less than, they're talking about addition or subtraction. All right, multiplication is product. Right? And then division is quotient. Just so you know, than works backwards, or turnaround word. Okay, so which expression represents 4 less than half a number n? So half a number n, 4 less than that. So then works backwards. So it's not going to be 4 minus, it's going to be minus 4 because then works backwards. So 4 less than half a number n. Okay, so that would be choice B. But again, they can use any of these math words for a problem like this. So make sure you know what quotient, product, more than, all those things and what they mean. Here's another translating into an expression from a word problem. Travis would like to buy some toys to donate to charity. He plans to buy 9 dolls at D dollars each, 2 toy cars at C dollars each, 3 train sets at T dollars each. Which expression represents the total cost in dollars that Travis wants to buy? Total, we're going to think addition. And if it's $9 per doll, $2 per car, $3 per train, and then I want to add all that together for my total cost. Right? So the only one that matches that is C. So again, $9 at D, 2 at C, 3 at T. And again, total cost, we're adding all those up. So I guess maybe for that previous slide, under addition, we should also say total is addition. A function is represented by the rule 1 more than 1/4 the square of a number x is y. Plot 3 points on the grid that represent this rule. Each point must have coordinates that are integers. So they want us to write an equation for that and then translate that into a graph. When it says it must have points that are integers, that means whole numbers. Okay, so they don't want any fractions for that. So again, more than means to add. So 1 more than, and it works backwards, and it's 1 more than 1/4 the square of a number x, and that is, okay, is your equal sign y. So first when I did this, you'll look over here, I typed it in and I got this graph, but it was kind of hard to see whole number points. I'm pretty sure there was one here at -4. It looks like there was one at -40, but I wasn't quite sure. Wait, that's a 0 there. That's the 0.10. Good Lord. Or 0. That's the 0.01. So it looked like 1, 1. And this looked like, I think this point looked like 2, 2, but I wasn't sure. So I decided to use the table to be sure. So I click on the plus sign and add a table. It will say x1, y1 when I first go in, but I replaced y1 with the expression 1/4 x squared plus 1. I make sure it said x1 because that's what we're doing every time. I gave it a choice of, I typed in 1 and it gave me 1.25, which is not a whole number. So I was like, oh, let me try 0. And that gave me 1. So I plot the 0.01. It did go through 2, 2. All right, gave it 2. And then I tried -2. And it went through there. So -2, 2 as well. So you know, if you put in 4, it also goes through the points. If I put in 4, it went 4, 5 was a whole number 1. -4, 5 was also a whole number 1. I think those are the only ones that fit from 0 to 10, because when I tried numbers bigger than that, it got bigger than the graph they gave me. But again, they only want 3 points. So it can be any of those 3 points you see graphed there. That is not, that's 5, 5, not 4, 5. Here we go. Oh, that's 3, 5. Good God. 4, 5. There. It could be any of those, any 3 of those points. But again, the way I got it, you can look at the table, and if you're sure it goes, or sorry, look at the graph, and if you're sure it goes through that point, you can. You could also type in the point underneath there, so I could type in, hey, does it go through 0, 1 underneath? And then it would give me that point. It's like, okay, it goes through there. But a good way of doing it is adding a table, replacing the y with this expression, so 1/4 x1 squared plus 1. All right, and then typing in numbers and trying to get whole numbers back. But again, the biggest trick though is knowing this expression, knowing that that is 1 more than 1/4 the square of a number x. So if that's how we got the exponent too, because it's the square of x. Square root, remember, is something different. Square root is this symbol, but they said the square of x, not the square root. So make sure you don't get that confused either. All right, now we're going to go over the exponent rules. Okay, so what we're going to do is we're going to, on the side here, go over exponent rules. These are really questions that can't be done in Desmos. Desmos is not helpful because there's multiple variables here, so you can't just type them in and get an answer. So we need to go over the exponent rules. So here's your rules of exponents. When you multiply, oops, so if you, and they have the same base, you add the exponents. When you divide, you subtract the exponents. When you do a variable, or sorry, a power to a power, so we have an exponent to an exponent there, we multiply those. If at the end of the problem I have a negative exponent, it goes on the bottom of a fraction, and then anything to the 0 power is 1. Or if you get a 0 power, it goes away. So those are the rules you need to know. If we're talking about coefficients of the big numbers, we use our traditional rules. So I like to break these problems down into their pieces. So I have 18 C8D9 all over 9 C3D3. So I'm going to divide my whole numbers, or my coefficients. So 18 divided by 9 is 2. So I know my problem's going to start with 2. They'll start with 9. Then I'm going to do C, where I'm dividing, so I'm going to subtract exponents. So I get C is going to be to the 5th power. And then D, again, I'm dividing, so I'm subtracting exponents. 9 minus 6 is 3. So the only problem with 2C5D3 is A. So if you know the rules, then break it down into its chunks to figure out what your new expression, your simplified expression, is going to look like. Again, I can't type that into Desmos and get an answer. So exponent rules, you've got to know. That's something that I would definitely take some time to study. All right, here's another exponent question. So again, I'm going to break it into its pieces. So first, let's take care of this parenthesis here. So we're going to take care of that first. So I'm going to distribute that 2 to both of these. So I'm going to have 3 squared, and then again I multiply -4 times 2. 3 squared is 9, and -4 times 2 is -8. So I took care of this part. I'm going to bring this part with it. So times 3x, sorry, that is not a 3, that is a 5. Negative 2, so I'm going to bring that part down. So again, break it into its pieces. 9 times 5 is 45. And then for the x, I'm going to do negative 8 plus the negative 2. Because I'm multiplying, so I'm going to add exponents, which is negative 10. And because it's negative, it's got to go to the bottom of a fraction. So let's see, 9 times 5 is 45. I need 10 at the bottom. The answer is C. So I took care of the exponent on the outside of that first parentheses first and distributed it. So 3 to the second power, negative 4 times 2. Simplified that. Then I brought down the other part of my expression that I hadn't used that yet. 9 times 5 is 45. I'm multiplying, so I add exponents. Negative 8 plus negative 2 is negative 10. I got a negative exponent, so it needs to be the bottom of a fraction. Again, I wouldn't worry about negative exponents till the very end. So at the very end of your problem, if you have a negative, put it at the bottom of a fraction. All right. Again, we're going to break this question down into its pieces. So let's see. A12 I'm dividing. So I'm going to subtract those exponents. So I get A9. Then I'm going to do 2 minus 6. Again, it's top minus bottom. And I get negative 4. This is going to go to the bottom because it's negative. So A9 on top, B4 on bottom. So the answer to that one is A. Again, study your exponent rules. It is extremely helpful to help, well, it's extremely necessary to know those in order to get those questions right. But once you know them, you can just break it down into its pieces. All right, here's another one. We're going to break break this question into its pieces. All right, I'm going to take care of top, that exponent on top, that exponent on the bottom. So I'm going to distribute this to here. So I'm going to have x negative 2. Then I'm going to have y negative 4 times negative 2. So on the top now, I'm going to have x negative 2, y negative 2 times negative 4 is a positive 8. Okay. On the bottom, I'm going to have x negative 5 times negative 1, and then y negative 6 times negative 1. So x positive 5, y positive 6. All right, still not done because first of all, it doesn't match any of my answer choices. And second of all, remember, you only want one x with an exponent and one y with an exponent when you're done. So I'm dividing, so I'm going to subtract. I'm going to do negative 2 minus 5, which when I put the negative 2 minus 5 in the calculator, I get negative 7. So that's going to be at the bottom. Then I'm going to do 8 minus 6, which is, y2. So I need y2 at the top because it's positive, x7 at the bottom because I got a negative. So the answer to that question is B. So distribute any exponents that are just sitting at the outside of a parenthesis and then simplify what is remaining when you are done. All right. I'm not 100% sure if questions like this will still be in the SOL, but I want to make sure we included one. All right, so they're giving us boxes and rectangles that represent expressions. And we just add them up and it'll tell us what we have. All right, and they want to know which one models the product, which means to multiply x plus 3, x plus 4. So if you look, here is the product of x plus 3, x plus 4. When I graphed it, you can't see it right now because it's underneath the solution. I got this parabola. All right. The key is if you want to know which one represents the same expression, if I go to graph it, and they're the same graph, they're the same expression. All right. So this one has 1, 2, 3, 4, 5, 6, 7, or I'm looking at letter A, 9, 10, I lost count, 9, 10, 11, 12. There's 12x squares here. When I graphed 12x squared, it did not look like that. It actually was over here. All right. So I knew that was not equivalent to x plus 3, x plus 4. This one has 1x squared. 1, 2, 3, 4, 5, 6, 7, 8. 8 x's. And then 1, 2, 3, 4, 5, 6, 7. 7 ones, so that was 7. When I graphed that, it didn't match. And then I tried this one. It has 1x squared, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 x's. I wonder if I lost count there. And then how many ones? 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. No, I definitely didn't lose count. When I graphed that, it was floating on, like it didn't overlap. And then finally, this one has 1x squared. It has 7 x's. And 12 ones. And when I graphed it, it was the exact same graph as x plus 3 times x plus 4. And in fact, it overlapped it. That's why you couldn't see the previous graph. So, since they are the same graph, they're the same expression. Okay, same graph, same expression. Okay, and you can use that a lot in comparing things with x's in it. If they have the same graph, they're the same expression. Okay, they're equivalent expressions. They represent the same expressions. All right, I'm going to use, again, we want to know which one's the equivalent expression. So which polynomial is equivalent to 18n squared minus 9n plus 1 divided by 3 minus 3n minus 1, assuming the divisor is not equal to 0, meaning that part means if 3n minus 1 equals 0, you couldn't do the problem because you have 0 in the bottom fraction. So they say, just assume that's not true. But the basic thing they're trying to get to is which one of these, A, B, C, or D, is this equivalent expression to the one they gave us. So again, I use x's. Okay, so I said, all right, let me graph this. All right, and again, I'm looking for same, good God, the same graph. Okay, which solution has the same graph? So when I did 6x minus 1, so again, I had to do 6x minus 1. When I type in this, it would be 6x plus 1. C and D were parabolas. They were curves that looked like this. So they didn't look like the original line at all. The original line is underneath here, but it was purple. And it was the same line here. Try to draw that in purple. Oh. So this was, was a purple line. And I graphed each one. The only one that had the same graph was A. A was the same graph. They're the same expression. The other thing you can look at is if I divide 8x squared by 3x, I would get 6x. When I divide 1 by 1, I get minus 1, by the way. So that's another way to check your work. But again, they want to know if an expression is equivalent to another expression. As long as there's just that one variable, you can graph it and see if they're the same. Unlike those exponent questions that we did earlier where it's like there's A's and B's, so there's more than one variable, so we couldn't do that. All right, so which expression is equivalent to this one? Again, there's two variables here, so technically we can't graph it and see. I'll kind of show you a cheat. But what I am going to do is I'm going to distribute 1/6 times those. So I did like, here you'll see I did like 1/6 times 30, which is, I got 5. I didn't want you to see all of it, but I did 1/6 times 24. Good God. Or negative 24 is negative 4y. Then I distributed negative 1/8 to these. So negative 1/8 times 32 was negative 4. Negative 1/8 times negative 16 is a positive 2. Right? So then I did 5x minus 4x, and I got x. And then negative 4 plus 2 is negative 2y. Then what I did to check my work, even though there was two variables, I was like, oh, let me just, this doesn't always work well. Whoops. You want to do that. Is I typed in this expression without the y and graphed it, and then I typed in each choice without a y and graphed it, and the x minus 2 matched up. But I think it's just as easy for this one is to distribute first and then combine like terms. But again, I checked it by typing it in without the y. See, there's no y there. There's no y there. I also didn't put a y over here. So I just left the y off and also saw that my answer choice graph was the same as my original graph, because my original graph was, again, a blue line going here. All right, which polynomial is equivalent to this expression? So again, it's a division problem. I put in x. It doesn't want to graph ends. If n doesn't equal 1, again, that's talking about if n equals -1, then it would be 0 at the bottom. That kind of stuff, again, does not really affect what you need to do for the problem. It's just saying, hey, the denominator can't be 0. So I graphed, and you see I got a purple line. Then I graphed each choice using an X. C and D were parabolas, so they were shaped like that. So they definitely match that line. The other line was way down here. Whoops! Oh no, I can't go back. Okay, so so will not let me go back to the previous problem. Well, let me click back. So I just want to kind of, as a side note, this should go on the previous problem. Make sure you chose the answer of B. It was the only one that overlapped. Also, if you look back at question 14, you'll see 3 divided by 1, so I'm just dividing the n's, is 3, and then negative 2n squared divided by n, so I'm dividing those n's there, is negative 2n. Right, but since there's just the one variable, equivalent expressions, I just graph it and see which one gives me the same graph using x. Now this one has more than one variable, so I can't just put it into Desmos. Okay, I might be able to check it by leaving like the b out of the problems if I go to check it. All right, but I'm going to distribute first. I'm going to multiply this negative times this negative times this, and the negative times that. So it becomes 2a 2a squared b cubed minus 10ab plus b squared plus, because a negative times a negative, 3a squared b3 plus, a negative times a negative is a positive. I say a negative times a negative is a negative and write a positive there. Negative times a negative is a positive. And then negative times negative is going to be a positive 17b squared. All right, combine like terms. This is like with this. 2 plus 3 is going to make a 5a squared b cubed. Negative 10 plus 20, because those are like, they both have they both have ABs, is negative 10 plus 20 is a positive 10. Positive 10AB, and then b squared plus 17b squared is 18b squared. So remember, distribute. All right, distribute before you combine like terms, and like terms have the same variables to the same power. Okay. Which of the following binomials is a factor of x squared minus x minus 6? So I'm going to graph that. If it was asking for the solutions, the roots, the zeros, or the x-intercepts, remember those are all the same thing. So that'd be negative 2, 3. Negative 2 and 3. That's where it crosses. This guy crossed the x-axis. So I graphed it. It crosses the x-axis there. The factors have opposite signs. So this crossed at negative 2 and 3. The factors have opposite signs. So this would go through x. The factors are x plus 2. Again, the name from zeros is because when I put a negative 2 into that, it gives me 0. And then x minus 3. So those are my two factors. They only give us one of them here, x minus 3. Okay, so which of the following is a factor? X minus 3 is a factor. The other one is x plus 2, but they don't have that listed. All right? So again, factors have the opposite signs of the x-intercepts. Have the opposite signs of the x-intercepts. Of the x-intercepts. Whenever you see, something where it's like x squared and there's an expression with it, you're always going to graph. You're going to graph it and you're going to get information from that graph. Okay, you're looking at the graph and trying to pull information of it. So if you're like, oh, I don't know what to do, you'd be like, hey, this isn't a trinomial. It's got the x squared on it. We graph it. That's where I'm going to get the information from. Solutions, roots, zeros, x-intercepts. It's all that x-intercept. Again, factors have the opposite signs. Which is a factor of 2n squared minus 5n minus 42. Notice when I type it in, I have to type in the x's. It only graphs x's. When I typed that in, I saw that it went through 60 and negative 3.50. So this would go through the x-intercept of minus 6, which is a choice right here. Just so you know, if it's ever a fraction, the way you match up the fraction is this is your numerator, that is your denominator. So that would go through the point 7/2, and a positive 7/2, which would, by the way, would be positive 3.5. But we got a negative 3.5 there. Okay, so when you go to do that, so if it's like, whoops, ax plus b, the one that goes with that is negative b over a. That would be the x-intercept that goes with that factor. Okay, opposite signs, the number divided by the coefficient of your x variable. All right, so factors have opposite signs of their x-intercepts. Look at the graph shown. Based on the zeros, so based on where it crosses the x-axis, which best represents the graph function? All right, first of all, there's a couple ways to do it. You could put these, you could put y equals x minus 3x with 2 in Desmos and see if it gives you the graph they're showing. So you could always just match the graph. But it's a little bit easier. This crosses at negative 1, or sorry, positive 1, positive 3. So I know two factors. So it's going to be x minus 1, x minus 3. And the only one that has x minus 1 and x minus 3 is choice D. But also, if I graph that in Desmos, that is the graph I would get. Okay, so that's another way to match it. Factors have opposite signs. Match your graphs. All right, identify each expression that is a factor of the polynomial. So I graphed this polynomial. It crossed at 1, and then negative 0.5 is negative 1/2. So this goes with the factor of x minus 1. This goes with x plus 1/2, but again, that's how you will put it. Okay, 1/2. So there's a factor, there's a factor. However, there's one more factor on this. Remember what I told you when we learned factoring, the first thing you should check is, can all my terms be divided by the same number? And if I notice, all three of those can be divided by 2. That is also a factor. Okay, so those are my three factors of this. Okay, all terms can be divided by 2. Also, if I graph 2x plus 1 and x minus 1, it would be the same graph as this. It would be a graph overlapping it. Okay, if I graph just 2x plus 1, x minus 1, it wouldn't be overlapping. Okay, it wouldn't be overlapping. So that's another way to check it. Again, your graph should overlap. First, I should check, can all these be divided by the same number? Yes, 2. Where's across the axis? A positive 1, so I had to choose negative 1. Also, these two can't be factors because those would have to cross on the positive side, but the other x-intercept I have is a negative, so it had to be 2x plus 1. Okay, that's for negative 1/2, 1 over 2, positive 1 over 2. All right, so 1, 2. All right, simplest radical form. If your simplest radical form is just numbers, type in your question. Okay, so type that in. When I got that, I got 4.24. Type in each of these, and when I type these in, if you can see on the side, I just typed them into Desmos. The only one that matched was this one. Now I need to be careful because sometimes more than one matches. If more than one choice matches, you choose the one with the smallest number inside the radical. You want this to be small as possible. okay? But it also has to match as a decimal. So even though I knew B matched, I went ahead and checked the other ones, okay? So if you notice, I checked all of them here, because if more than one matched, I'm going to choose the one with the smallest number in the radical. All right. Here's another one. This one, though, has just has a variable in it. By the by, I could graph this in Desmos, and only one of these will have a matching graph. Okay, so that's one way you could do this problem if you wanted. Okay, only one of those has a matching graph. The other way is I typed in the square root of 42 into the calculator, and I get 6.48 when I did the square root of 42. Let me write this over here. And then I typed in 6 square roots of 7. Notice I'm typing without the variable, and I got 15.87. Those can't be it. Okay, that is not the same as the square root of 42. By the by, this n is greater than 0. Again, I can't have a negative number in a radical. It doesn't affect how I solve the problem. It's just setting up the problem so it's possible to solve. Because if your n was negative, this wouldn't be a solvable problem. It'd be not a real number. All right, but again, this doesn't really control what we're solving. For square roots of variables, you divide the variable by 2. So that's going to be a divided by 2. All right, so you divide the exponent by 2. All right, so 9 divided by 2 is 4 with the remainder 1, or 4.5. So this would be 4 on the outside, the remainder on the inside. So the only one that's left with 4 on the outside, 1 on the inside, oh, they're using n's, I use x's, whatever, is b. Okay, so the square root of 42 matched. Okay, that couldn't be simplified anymore. It's a simplified 1. All right, and then 9 divided by 2, because it's a square root, so you divide by 2 is cube root divided by 3 when it comes to variables or exponents. All right, I got 4.5, so that means there's a remainder inside the radical. The 4 on the outside, remainder on the inside. Identify each expression that is in simplest form. So, in order to be simplest form, what's inside the radical? All right, it cannot be divisible by a perfect square. And for this SOL test now, and no exponents, and that's on the end exponents. That's for the end side. Again, square roots. This only works for square roots. When you get to cube roots, it changes a little bit. But for as terms of this SOL test, all right, to be in simplest form, you can't have any exponents inside the radical. This is not in simplest form. Also, the number inside the radical cannot be divisible by a perfect square. So if you look here, that is divisible by 25. 25 is a perfect square. This is not in simplest form. This is in simplest radical form because, again, it doesn't matter what's going on outside the radical. Who cares? You could have whatever you want outside the radical. Inside the radical is just x. It doesn't have an exponent. So don't need to worry about that. For this one, this is also in simplest radical form. X and y, they don't have an exponent, and the 2 cannot be divided by a perfect square. There's no perfect square that goes into 2. So those are the 2 that are in simplest radical form. Okay, so for this test, we're checking to make sure there's no exponents inside the radical and that it cannot be divisible by a perfect square. Okay, look at the expression. 3 square root of 45 minus the square root of 20. Simplify the expression. Again, there's no variables here, so I'm going to type this in and get a decimal. And then type all these in and see which one gives me the same decimal. Again, if more than one does, I choose the one with the smallest number inside the radical. So this is the one that matches. No, it is not. This is the one that matches. Okay, so I choose B. When I typed in that expression, I got 15.65 with a bunch of other numbers. The only one that gave me the same expression was 7 square roots of 5. Okay, so type them all in, see which one matches. Same thing. So all those rules also work for cube roots. You know, you can always match them up. For this one, there's nothing to match up, which I'm pretty sure in the S will anything with the cube root, because it's going to be, you might be able to type in something with a cube root there. But just so you know the rule for that, when you're multiplying roots together, if you remember when you're multiplying roots together, if there's numbers on the outside, you multiply them together, and numbers on the inside you multiply together. So we assume there's a 1 here, because it's just there. So I'm going to do 1 times 4, and then 18 times 3 is 54. All right. So I get 4 on the outside, and on the inside is 54. All right. Again, there's nothing to match, so I can think, okay, what is a perfect cube that goes into that? A perfect cube that goes into 54 is 27, and it goes in there twice. The cube root of 27 is 3. I can type that right into Desmos. I get 12 cube roots of 2. 4 times 3 is 12. Again, type it in, make sure it matches. Okay? Type it in and make sure it matches. Again, you can always work backwards, so to check your work. So cube roots work the same way. I almost can be sure that if they do a cube root, by the way, it's like a drag and drop where you would drag in the right things to make sure it works. Again, you would just type in to see until it matches. Okay, or it'd be multiple choice. Just in case it isn't. Remember, find a perfect cube that goes into it. Or multiply the outsides together, multiply insides together. If the inside isn't simplified, see if there's a perfect cube that goes into that. Find that root, and then multiply times what's on the outside.